last class we have studied about kinetic energy and potential energy by giving proof of these two formulas. Now today we will start the law of conservation of energy. The statement of the law of conservation of energy is that energy can neither be created nor be destroyed. If it's created, it must be converted into another form, and it remains always constant in the universe. So we first write the statement: energy can neither be created nor destroyed in the universe if it is created it can be converted into another form. Converted into another form and remains conserved. In the universe. Now we will prove this law of conservation of energy by taking an situation of free falling object. The free falling object has sense. Any object is falling under the control of the gravity of the earth. So let us see how to prove this. Basically, the total energy possessed by any object is the mechanical energy, where kinetic energy and potential energy are added up, and that gives the total mechanical energy of the object. So during free fall of the object, we will calculate and find the total energy of the object at three different points. One, the point from where the object starts to fall freely and turns under the gravity, control of the gravity, and when it falls on the earth, and before falling, just above the earth, in between the point of fall to the on the ground, and from the point of fall to the point of fall on the ground, in between the two, we choose any one point at certain distance from the top of the height, and we make use of adding kinetic plus potential. Now let us see how to prove the law of conservation of energy in the case of free fall object. For free falling of object, proof. We just decide one certain height above the ground. This is our fixed ground. A is the point from where the object is start to fall with the velocity 0. M is the mass of the object falling. The object is falling continuously and comes to any new position. We think that the object comes to the position from A to B. Now from A to B, the distance covered by the object is x. It acquires certain velocity at the point. We write it as Vd. So the body moves from rest position at certain height to the B position to acquire the velocity at B. C is the point on the ground. The total height of the object is h above the ground, from where the object is falling freely under the control of gravity. Now remaining height is here h minus x from the ground. Now at A, we find the total energy, kinetic energy plus potential energy at the point A. So write total energy at A. Kinetic energy is here half m 0 square plus mgh, total potential energy at A. Because object has initially zero velocity when it start to fall, so the kinetic energy is here 0 due to the velocity equal to 0. And above the ground at certain height the object passes maximum potential energy mgh. So we add up to write 0 plus mgh and we get mgh equation 1 at point A. When the object falls to the point B, by describing the distance x, the total energy at B is similarly kinetic energy at B and potential energy at B. So kinetic energy is here half mv at B square plus potential energy of the object having mass m is here mg remaining height h minus x. Now how to write the value of the velocity by equation of motion? By equation of motion we can write velocity at B square, velocity coming from the A point to gx. The velocity at A is the initial velocity of the object and velocity at B is the final velocity acquired by the object during free fall. So we get velocity square is equal to 2gx. Making use of the v square 2gx in the equation for total energy at B, we can write the total energy at B 1 by 2m, v square is here 2gx and mgh minus mgx. Now we cancel out half with the 2 digit multiplied to gx. We get mgx plus mgh minus mgx. We cancel out and we get the formula for total energy at B as equations 2 for EB total at B mgh. But when the object falls down to the ground, then we write total energy at C. When the object is falling freely, it passes kinetic energy and loses potential energy. When the object falls down, it acquires maximum potential kinetic energy, half v square at point C, and potential energy at C is 0. Potential energy at C is 0. How to write the value? During free fall, once again equation of motion is utilized. Equation of motion is utilized when the object falls from the velocity 0 to acquire the velocity at C, maximum velocity acquired by the falling object. So velocity at c square coming from a 0 to g h, the total distance described by the object. So we get v square as 2gh, and we put the value for finding the total energy 1 by 2 mass, and v square is here 2gh. So 2 is cancelled out, we get the value mgh. This is the third equation. So from all equation 1, 2, 3 we get the total energy possessed by the object is mgh, which is the same. And in the case of third point C, the total energy has been converted into kinetic energy, half mv square at C. So initially when the object was at A, it possesses only potential energy, and when it falls down, come to the ground to acquire the velocity vc, it acquires total kinetic energy only. So there is conversion of potential energy into kinetic energy, and at every point during the free fall, the total energy remains the same, mgh. So this proves the formula.